and look at how we can design a good primer. Okay, fine. Now you can see that there is a folder, and you have the useful link for the software download. You can copy this link and then you can paste it in the Chrome or anything. Okay, so this is the window which will come, and if you observe in the primer 3 plus, you have an option for qPCR. So you activate the settings for the qPCR and you paste the sequence which is shared with you this file, right? You can go and read what these general settings are. I will just quickly go with some of the settings. As you see that for the qPCR in the primer 3 plus default setting, it's 18 minimum primer size, 20 is optimum and 23 is maximum. Similarly, you have a melting temperature of 58, 60 and 62. So it means that this is the melting temperature of the primer or of the product which you are going to choose. So 60, right? GC content is 30, 50 and 80. So what we will do is that we will leave all these parameters constant. We will leave all these parameters constant except this. So what we choose is the product range between 100 to 120, and we will see if it returns with some of the primer combination or not. So here you have a number of settings. Basically, some of the common and useful settings I will be just discussing. As for example, self-complementary. What this means, I will just show you. Template mispriming. Mispriming is something, it means that your primer is not going in binding to some other region within the genome or within the RNA. Okay, so we will pick the primers. Okay, so what it gives you a 5 pairs of primer, right? Mostly in primer 3 plus, it gives you 5 primer list. The first one is most often it is a good one in comparison to other, and how it define is that by giving the penalty score. If you will observe here, the penalty score for this primer is 5.7, whereas for the second one is 7.5, third one is 7.6, fourth one is 8.1, fourth one is 8.1 and fifth one is 8.2, right? So what we did is that we pasted the primer sequence which I had given you in the Google Drive in the primer 3 plus, right? And in the primer 3 we have chosen qPCR and activated the setting. In that you pick the primer and then you will see a list of 5 primers. One is having a penalty score of close to 5.1, second one is 5.6, third one is 6.0, fourth one is 6.1. Oh, sorry, I think I didn't. Okay, so here you have 2 primers. Now you will see that it is having a melting temperature of around 60. So forward and reverse both. When we choose the primer, we should keep the melting temperature close to less than 3 to 4 degree for forward and reverse, right? So based on all the parameters, it calculates the penalty. So lesser the penalty, better the primer in the primer 3. Okay. So I asked you to also install oligo analyzer. Basically, it's a supplement one. It is not mandatory to use oligo analyzer. But what we will do is we will see what self complementary and loop and all those things are. So we will copy this particular primer, which is selected by primer 3. We will paste here and we will look into the property. Now, if you see that this primer is having a potential to form I mean in self-annealing, it's with a very high delta G value. So the lower the delta G value is, it means that the more negative it is not good. So what you can do is that you can customize by just removing one G maybe, and then you can look again. Now you will see that the delta G value is close to minus 0.3, right? So this helps you in customizing the primer, which even primer 3 is giving you with the best possible combinations, right? Now in the screen, if you can see, how can I make this screen visible? Yes. So in this screen, you will see that it is forming a loop. So this is the loop. It means that the forward primer, after around 10 bases, has the potential to form a loop because 3' end is complementary to the 5' end, right? So these things which we need to look when we are designing a primer. It should not form a loop, and even sometimes if it forms a loop, the delta G value, which is, I mean, the more negative value is the more spontaneous reaction based on the chemistry concepts, if we remember. What happens is that the more delta G value, I mean, the more delta G value in negative, so it means minus 6, minus 7, minus 10, increases the chance of forming the loop, whereas if it is close to 0, there is a chance that this will happen in a lesser rate, right? So these aspects you need to check when you are designing a oligo. So basically what you do is that you select the gene of interest, you design the primer using primer 3, and then you look forward and reverse base using oligo analyzer. Now this is the case with the forward primer. What happens to the reverse primer? So you can add a primer here and then you can look. Now you will see that the reverse primer is good because it is not forming any self-annealing or any loop, right? So what happens? The first primer, you saw that it is forming some self-annealing and one loop, but none of them are having a very high negative delta G value. So what it says that this primer could be used. It can be a good primer. Whereas in the reverse primer, you will see that it is not forming any self-annealing or any loop. So that is also good, right? So this is how you design a primer. Now, if you would like me to repeat once, I will just do it quickly, right? Okay. So let us repeat the whole thing. Follow me carefully. I am repeating it. I give you two files. One is useful links for software download, which is having a link for primer 3 plus. You copy this and then you open it in the your browser, right? Now, in the load server setting, since your aim is to do the qPCR, you can click on the qPCR and activate setting. Right? By the time the setting is activated, you minimize this and you will see the second file which I have shared is a primer. I mean, it's a gene sequence. which we will be used to design the primer. So we will copy it and we will paste here, right? We'll go in the general settings and we will keep around 100 to 120 product size. Product size, it means the amplicon size of the target gene, and then some of the parameters which I will share the PPT where you will see that what should be the optimal condition to uh, design the primers, right? And then we will go for peak primers. Now it has given you a primer which is having a penalty of 5.7. Penalty is actually calculated based on all the parameters, like whether it is following, you click on penalty if you have doubt, and you can see that based on all the condition which is not following promptly, as for example whether the 3' stability is good or not, because 3' where the PCR reaction starts, or the where it goes an annual and the amplification starts. So if the stability is high or not, if the high is the stability, better, lower is the penalty, and that will be reflected over here. So basically in primer 3 plus, lower the penalty and it will be the better primer. In order to cross-check whether the primer of 103 base pairs which primer 3 has picked for you for this particular gene, you copy this, you click on oligo analyzer, and then you check the property. Now the default property says that it has the potential to make the self dimer, because in the 5' end you have the complementary bases, 4 complementary bases. So there is a possibility that it will make the self dimer. What you can do is you can remove one G and customize your primer, right? And now you will see that it is a very less chance, or the reaction, it's not that spontaneous, because the delta G value is not so in negative. So that means this primer is okay now. Other thing what you need to check, what is the loop. You will see that this primer is also forming a loop. So another good advantage is that you can also remove one base from the 3' end, and then you can check. Now you will see that the loop is also less, and the annealing is also with a very minimal del G value, right? So it means that this primer could be used. Now you can add primer, and you can do the same for the right primer. It means the reverse primer, right? And then you can analyze. Now you will see that this primer does not do the self annealing or is not forming any loop. So it reflects that your this primer is good, right? So this is how you can check the forward and the reverse primer. If at all you are interested, you can also do the multiplexing, and then you can check whether it can make the heterodimer or not. Now in this particular example, you see that there is a chance that this two primer will form the heterodimer with a del G value of minus 3.7. In most of the cases, again, it's not a hard and fast rule. But if the del G value is less than minus 4, or I mean, yeah, less than minus 4 or minus 4.5, it means toward minus 5, minus 6, minus 7. The chances of heterodimer is way higher, right? Whereas if it is less than zero point 0.3, zero point 0.2, zero point 0.1, then it can be used. So in this particular example, if you are very much sure that this gene is it's a one copy gene in your genome, then you can use this primer. Otherwise, you can look back again and then look for the second set of primer, third set of primer, fourth set of primer, fifth set of primer, and then analyze at your experience, right? So this is how you design the primer. Now I have shown you the example of what is self annealing, what is loop, and what is once you do the multiplexing, what is the heterodimer, right? In the heterodimer, I mean the forward and reverse are not. Yeah. So this is how the heterodimer looks, right? So heterodimer means that the forward and the reverse primer are having complementary bases with the potential to anneal together. So that is heterodimer, right? And you can always use a different combination of first or the second primer uh, depending on the product length. So if, let us suppose, if it is starting from 470, then you cannot use the reverse of 913, because forward and the reverse, then the difference will be close to 450 base pair, which is not supported by the real time machine, right? However, you will see that the second and the third PCR, the start is at 814 and the end of primer 3 is 1052. So it means that these two combination also you can check in the oligo analyzer and decide that whether it is forming any self complementary and heterodimer, right? So this is how you design the primers. I hope that it is clear to everyone.